Hey guys, Mr. Backerberg here. In this video, we're going to look at transformations of sine and cosine graphs. So the first thing I want to look at is what's called a sinusoid. And a sinusoid is a function that can be written in the form f of x equals a times the sine of bx plus c plus d. And in this function, a, b, and c are going to be some constants, but we need to make sure that a and b are not zero. Now, technically, a cosine function is a translation of a sine function. So any cosine function can also be written as a sinusoid. So we could also see a function written in terms of f of x equals a times the cosine of bx plus c plus d. That also technically counts as a sinusoid. Now, all of these values, a, b, c, and d, are going to affect our functions and affect the graph of our functions in their own way. Now, as we're looking at graphing out a basic sine function, so just f of x equals the sine of x, we're going to make an x and y chart. And for the x values, I'm going to pick nice angles off of my unit circle that give me easy y values to plot out. And those angles are going to be those quadrantal angles of 0, pi over 2, pi, 3 pi over 2, and 2 pi. And you'll see why I picked those values in just a second. Now, as we're evaluating this function, we're just taking our x values and plugging them into our function, and then we're going to use our unit circle to help us evaluate this. So if I plug in 0, that means that we have to take a look at the angle 0 on our unit circle, and as we're looking at the unit circle, the sine is the y value. So the sine of 0 is 0. Now, if I plug in pi over 2, we find pi over 2 on our unit circle. Again, we find the y value since we're doing the sine, and the sine of pi over 2 is 1. If I plug in pi, the y value from the ordered pair at pi should be 0. If I plug in 3 pi over 2, that y value from the ordered pair is negative 1. And if I plug in 2 pi, the sine of 2 pi is 0. So you can see that I picked these x values because they give me nice y values to plot out on my graph. So I'm going to say that 1 is up here, and I'm going to say that negative 1 is down here. So first I've got the point 0, 0. And then I've got the point pi over 2, 1. So this first dash mark along my x-axis, we always get to pick the scale on our graphs. So I'm going to say that that first dash mark is just an x value of pi over 2. So at pi over 2, I'm up at 1. This next dash mark I'm going to say is pi, and we're supposed to be at 0 there. This next dash mark I'm going to call 3 pi over 2, and we're supposed to be down at negative 1 there. And then this last dash mark I'm going to call 2 pi. And at 2 pi, we're at 0. And if I connect these points, that's going to give me my nice sine wave that we should end up with as we're drawing this graph. Now, I picked these 5 points because it's going to help me complete one full cycle of my wave. I started at 0, I went up and hit the maximum, came down, hit the minimum, and then I went back to 0. So this is one full cycle. This is one full period of the sine graph. Now, I can do very similar things for the function f of x equals the cosine of x. So I'm going to make an x and a y chart, and I'm going to use the exact same x values, those quadrantal angles, from my unit circle, just so I end up with nice points to plot out on my graph. These are going to be my x values, so I'm going to label my axes. So going across my x-axis, I've got pi over 2 and pi, then 3 pi over 2 and 2 pi. Now, as we're evaluating the cosine, when we plug these x values in, we're still going to look at our unit circle, but as we're looking at those ordered pairs, we need to focus on the x values. So the cosine of 0, if I look at the ordered pair, the x value there is 1. The cosine of pi over 2, the x value of that ordered pair is 0. The cosine of pi should be negative 1. The cosine of 3 pi over 2 should be 0. And the cosine of 2 pi is 1. So I'm going to plot these points out on my graph. So at 0, I'm up at 1. At pi over 2, I'm supposed to be at 0. At pi, we're down at negative 1. At 3 pi over 2, we're back to 0. And at 2 pi, we are up at 1. Now, if I connect all these dots, this should give me my cosine wave. And again, I picked these 5 x values, and we got these 5 points, because that's what helps us complete one full cycle of our graph. Now, those were pretty basic sine and cosine functions, but we're going to start performing some transformations with them. And the first thing we're going to look at changing is the amplitude. And the amplitude of a sinusoid is the absolute value of the a value. So whether we're looking at a sine function or a cosine function, we're going to focus on the a value in front of the sine or in front of the cosine. And graphically, the amplitude tells us half the height of the wave. So as we looked at those sine and cosine graphs, there was technically a 1 in front of our sine and our cosine, which meant that our wave went up one space from kind of the middle point, and it also went down one space. But now as we're adjusting our a value, that's going to make the graph go taller or shorter, depending on what that a value looks like. Now we're going to look at performing a vertical stretch or vertical shrink by looking at the amplitude of a function. So I've got a copy of our cosine graph that we came up with earlier, and we're just going to use the cosine for this example, but the same information would hold true for a sine graph as well. So I've got that x and y table that we made earlier, and that gave us these ordered pairs that we plotted out on our graph. And what we're going to do is we're going to look at two new cosine functions with their a values changed. Remember, this initial cosine function technically has a 1 in front of it, so that's why we were getting this 1 and this negative 1 as our y values. But now in our second function, in this g of x function, now there's a 2 in front of my cosine. So the 2 is going to affect how high my waves go and how low my waves go. I'm still going to use the exact same x values, so I'm going to use the 0, the pi over 2, pi, 3 pi over 2, and also 2 pi. But now what's going to happen in here is with these y values, it's going to be very similar to what we've got in our initial table, but what I need to do is take all of those y values that we originally had, and because we've got this 2 multiplier out in front, I need to multiply all of these answers by 2. So for my first ordered pair, where we had 0, 1, well, if I take the 1 times 2, then we're going to get a y value of 2. So that gives me the new ordered pair, 0, 2. For my next ordered pair, I had pi over 2, 0. But if I take the 0 times 2, I still get 0. Then for my next point, I'm going to have to take the 2 times the negative 1 to get negative 2. 2 times 0 is still going to be 0, and 2 times 1 is going to be 2. So now I get all of these new ordered pairs to plot out on my graph. So I'm going to say that 2 is up here, and I'm going to say that negative 2 is down here. So at 0, I'm supposed to be up at 2. At pi over 2, I'm at 0. At pi, I'm down at negative 2. At 3 pi over 2, I'm back to 0. And at 2 pi, I'm up at 2. So now I connect all those dots to get my cosine wave. And now notice, because of that 2, the only thing that changed was the height of our waves. So our waves got taller. Now as I look at my third function here, h of x equals 1/2 cosine of x, I'm going to use the exact same x values again. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. But again, we're going to have to adjust the y value. So I'm going to look back to my original cosine function. But because I've got that 1/2 multiplier out in front, I'm supposed to multiply all of these y values by 1/2. So if I look at the 1 times 1/2 is 1/2. 1/2 times 0 is 0. 1/2 times negative 1 is negative 1/2. 1/2 times 0 is 0 again. And 1/2 times 1, we're back at 1/2. Now 1/2 is going to be about right here. And negative 1/2 will approximate that to be right there. So at 0, I'm supposed to be at 1/2. At pi over 2, I'm at 0. At pi, I'm at negative 1/2. Then at 3 pi over 2, we're back to 0. And at 2 pi, I'm up at 1/2. So now I can connect all those dots to get my cosine wave. And we get a picture that looks something like that. Now that green graph, since the waves got taller, that's a vertical stretch. And my blue graph, since the wave got shorter, that's a vertical shrink. That's going to be it for this video. Thanks for watching.